Welcome back to Dave Does Math from Home. We have here a double integral on a non-rectangular region. If you haven't watched video 1 of this isn't going to make any sense. So watch that video, start watching this one, it will be clear. We're just going to dive directly into evaluating this integral. So first thing that needs to happen is we're going to integrate this function with respect to y. The outside integral, this x equals 2 to x equals 10, that's going to stay there. The dx, we'll deal with that later. We just need to integrate this thing. 8xy with respect to y should give you 4xy squared. We're evaluating that at 1 and negative 1/2 x plus 6. And then you have to plug these things into your y value, just like always. I'm trying to write small because I know this is going to get, there's a lot to do here. X equals 2 to x equals 10. Okay, we're going to have 4x times negative 1/2 x plus 6 squared minus 4x times 1 squared dx. This is me plugging y equals this into here, and y equals this into here. We have to do a chunk of simplification here to make this thing reasonable, but that's okay. We're all algebra experts. We can do this pretty handily. So this is going to be 4x times, when you square this, you should get 1/4 x squared minus 6x plus 36 minus 4x. Not so bad. Dx. So I'm going to keep simplifying it. I want to distribute this 4x in here, and then I want to combine like terms when it's all done. So I'll have an x goes from 2 to 10 of, this will be an x cubed. This will be minus 24x squared, and this will be plus 154. Is that right? 4 times 30 is 120. 4 times 6, so 144. Oh, that makes sense. It's a multiple of 12. Okay. So this is going to be 144x minus 4x. So I'll call it 140x dx. Now that the simplification is done, we can pause and we can check to see whether or not that thing I said in the last video is true. We have finished the inside integral. Y has been integrated, y has been substituted, y has been evaluated. We need to check if the thing that we're left with is free from y values. And it looks like it is. This thing at this point is just a function of x's. There's a lot of x's going on. We have an x cubed, 24x squared, 140x, but it's just x's. No y's left, so we're in the clear. So I'm going to bring it up over here to evaluate the second integral, which I think is going to get a little bit out of hand. We'll do our best. Here we go. X cubed is going to turn into 1/4 x to the 4th. This is going to turn into 1/4 x to the 4th. This is going to turn into x cubed, negative 8x cubed. This is going to turn into 70x squared, and that's it. We're going to evaluate this from 2 to 10. Time for an entire festival of arithmetic. 10 to the 4th is 10,000. 1/4 of that is 2,500 minus 8,000 plus 7,000. That wasn't so bad. So this is what happens when you evaluate at 10. Minus 2 to the 4th is 16 times 1/4 is 4. 2 cubed is 8, times 8 is minus 64, and 2 squared is 4, times 70 is 280. So, if you need to use a calculator to do this, please use a calculator. I'm not interested in policing that right now. Do the calculator for the arithmetic. I mean, when you do double integrals on tests and quizzes, I do want to see all of this work, because you're doing it by hand and not using an online integral calculator. But for the arithmetic at the end, use one of those simple basic arithmetic calculators. That's fine. This is negative 1,000, so that's going to be 1,500 minus, that's negative 60, plus 280 is 220. So this, I think, final answer is 1,280. Not so bad, right? You do the integral like normal, plug in your functions, simplify your functions, plug in your, integrate on your other variable, plug in your numbers. It's long, and it is unfamiliar. But it being long is not a huge problem. We can muscle through these being long problems. It will just take us a little while. And it being unfamiliar is a problem we can solve. We just got to do a bunch of them. So, hopefully this is not as bad as it seems. I'm going to erase all of this and evaluate the integral backwards using dy dx instead of, I'm sorry, we just did the dy dx version. We still have the dx dy version written down from the first part of this video, so I'm going to do that one next and make sure that we still get 1280. The other integral was y goes from 1 to 5, x goes from 2 to negative 2y plus 12. We're still integrating the same function with respect to x first this time. So, to integrate with respect to x, we're going to leave this y integral alone. We're still going to go y equals 1 to 5. This integral should be 4x squared y. We're going to evaluate that at x equals 2, and x equals negative 2y plus 12, and then we'll slap a dy in the end. So now we evaluate this. The outside integral, y goes from 1 to 5, not changing. That's just going to hang out for a while. I'm going to put the 4 and the y together so that I can just plug these things in for x and not worry about what's in front and what's behind. So I have 4y times negative 2y plus 12 squared. And then I'm subtracting from that 4y times 2 squared. And I still have my dy attached to the back end. I need to evaluate this thing. Y is going to go from 1 to 5. 4y is going to hang out for now. Negative 2y plus 12 squared should give me a negative 4y squared. 24, 48 minus 48. I say 48 when I write a different thing. Minus 48y plus 144 minus 416 minus 16y. So again, we need to distribute this 4y in there and then combine some like terms. So this will give me y equals 1, y equals 5. This part's still not changing. This should give me 16y cubed 4 times 48 is, 2 times 48 is, should be just less than 200? 8 less than 200? 192? Minus 192y. 4 times 144, that's kind of a doozy. So that'll give me 400 plus 160 plus 16 is 576. But 576 minus 16y should leave me with just 560. Plus, sorry, this is y squared, 560y. Okay. So I'm pretty sure that's correct. I'm doing it in my head. If I get the wrong answer at the end, I know what the right answer should be, I think, unless I made a mistake on that one too. If I get a different answer at the end, we'll just assume I made an arithmetic mistake, and we'll pretend it never happened and never talk about this again. Okay. So, at this step we can check to see what's going on. Do we have any x's left? The answer is no. We're out of x's, so we can keep going. Charge forward. The integral of 16y cubed with respect to y is 4y to the fourth minus, I need to divide that thing by 3, huh? Oh, that's divisible by 3. Probably 60 something? 64? 64 times 3 is 180 plus 12? Yeah, okay. So negative 64 y cubed. Got to divide this one by 2, and I think that'll give me 280. 280y squared. We got some ugly looking numbers here, but I'm just glad we don't have fractions. Tossing that 8 in front of this thing was a good call, I think. So this is my integral, 16 over 4, 192 over 3, 560 over 2. We need to evaluate this at y equals 1 and y equals 5. So 4 times 625 should be 2500. 64 times 125 is the same as 16 times 500 is negative 8,000. Are we getting the exact same numbers? That's cool. I knew we were going to get like the same eventual answer in the end. I didn't know it was going to line up quite so closely. I'm guessing this is 7,000. Let's see, 25 times 280 is going to be 100 times 70. Yeah, 7,000. Plus 7,000. That's what happens when we evaluate at y equals 5. When we evaluate at y equals 1, we're getting 4 minus 64 plus 280. Yeah, the exact same numbers in the exact same places. That's actually very interesting. I did not know that was going to happen. So, we know that this is going to turn into 1,500 minus negative 60, 200, 220, which will leave us with 1280. We did it. We got there. Okay, so this is 14 minutes into the second video, and we have completed one problem. We did it twice, and I talked a lot about theory while we did it, but I'm not going to lie to you, these are not short problems. I didn't assign a lot of them on the homework. There's 12 homework questions for this section, and they're not all start to finish, set up the integral and evaluate the integral. A lot of them are just set up the integral. A lot of them are just evaluate the integral. Some of them are, here is an integral, set up what the integral would look like if you switched the order. So those problems are fun. The trick to doing those problems is to look at the current order, draw those functions, figure out what region you have with a picture, and then just create a new integral using those regions. Don't try to do some process to these things to switch the order. Don't just. I'm sure there is a process, but it's probably exhausting and confusing. Just draw a picture of what these functions look like, and then make a new integral based on that picture. We're at 15 minutes, and obviously I should not start a second problem with only 4 minutes until this camera cuts me off. So I'm going to cut this video here, but we're going to do a part 3 pretty much immediately. Stay tuned.